Working with vectors. The direction of the vector may be measured by an angle theta from some known reference direction. Consider this picture again. The direction of the vector v may be measured by an angle theta from some known reference direction. As shown in this picture. Figure 1.1. Is theta. The negative of v is a vector of minus v. Is a vector having the same magnitude as v, but directed in the sense opposite to v, as shown in this picture. This vector must obey the parallelogram law of combination. Obey the parallelogram law of combination. This law stated that two vector v1 and v2 v1 and v2 treated as force vector figure 2 1 2 8. This picture, let me provide the picture, may be replaced by their equivalent vector. These two vectors replace it with the their equivalent vector v which is the diagonal of the parallelogram formed by parallelogram formed by v1 and v2. As shown here. This combination is called the vector sum. V equals to V1 plus V2. Consider the picture here again. As we said that V1 plus V2, where the plus sign when used with the vector quantities means vector and not a scalar addition. The scalar sum of the magnitude of two vectors is written with the scalar sum of the magnitude of the two vectors is written in the usual way. V1 plus V2. The geometry of the parallelogram shows that V and is not equals to V1 plus v2. The two vector v1 and vector, again treated as the fourth vector, may also be added ahead to tail by the triangular law. You can see the picture also. We can use the triangular law. The two vector v1 and v2, again treated as free vectors, may also be added ahead to tail by triangular law. This picture, figure to obtain the identical vector sum. v1 plus v2. We see from the diagram that the vector of addition of vectors does not affect the sum, so v1 plus v2, v2 plus v1. Consider this picture again, the difference v1 minus v2 between the two vectors is easily obtained by adding minus v2 and v1 as shown in the figure 1-3 in this picture, where either the triangle or parallelogram produce a procedure triangle of parallelogram procedure may be used. The difference v prime between two vectors is expressed by this relation v prime v1 minus v2, where the minus sign denoted vector subtraction. Denotes vector subtraction. Any two or more vectors whose sum equals a certain vector v are said to be components of that vector. Component of vectors. Any two or more vectors whose sums equals a certain vector v said to be the complement of that vector. Thus the vector v1 and v2 in this picture let me provide vector v1 and v2 in the figure 4a are the components of the in the direction 1 and 2. Respectively, these two vectors are the component of the vector v. It is usually most convenient to deal with vector components which are mutually perpendicular. Most convenient to deal with vector component. Which are mutually perpendicular these are called rectangular components. The vector Vx and Vy in the figure A1 for V, this figure and this vector. Likewise, in the figure C, Vxy' and Vy' also are perpendicular components. When expressed in rectangular component, the direction of the vector with respect to, say, the x-axis is clearly specified. The angle of the verb theta in figure 1 for B, this theta equals to tangent inverse Vy y component on x component. A vector V might be expressed mathematically by multiplying its magnitude V by a vector n whose magnitude is 1 and unit vector. A vector V may be expressed mathematically by multiplying its magnitude V by a vector n whose magnitude is 1 and whose direction coincides with that of V. Coincide with that of V. The vector n is called a unit vector. The vector n is called the unit vector thus z equals to in this way the magnitude of direction of the vector are conventionally contained in mathematical expression. In many problems, particularly three-dimensional ones, it is convenient to express the rectangular component of V as this picture. As I said, in this way both the magnitude and direction of the vector are conventionally contained in one mathematical expression. In many problems, particularly three-dimensional ones, it is convenient to express the rectangular component of V as this picture, term of unit I, J, and K. In many problems, particularly three-dimensional ones, it is convenient to express the rectangular components of V as shown in this picture. We go by figure 1.5, this picture. In terms of unit vectors, I, J, and K. Okay, which are vectors in x, y, and z direction respectively. In the pictures in the direction. With unit magnitude, because the vector V is the vector sum of the component A, x, y, and z direction, we can express V as follows. V is a vector sum of the components in x, y, and z direction. We can express v bx I by j bz k. We now make of the direction cosine n, m, and n of v. Direction L equals to cosinus theta x as shown here. Theta x m cosinus theta y and n cosinus theta z. Thus we may write the magnitude of the components as this. Vx m and vz and v2 equals to vx Note that we have this relation also L2 equals to 1. This is the principles of for them working for with vectors in statics. The next section is Newton's law.